Hello YouTube, this is a continuation of the famed Monty Hall riddle paradox in using the smartest woman on the planet, so to speak, Marilyn Vos savant with the highest IQ, went against conventional wisdom and logic. And if you don't know what I'm talking about, the old three-door, you pick a door, and the game show host opens one door, the other door to see that it's not the winning prize door. Would you like to change your option? And it's 50-50. Well, Marilyn Vos savant's logic is you should change it. Now, I will disagree with her on the three-door logic, but using many-door logic, is as follows. So she suggests you should always change your answer. So what we're going to do, conventional wisdom says 50-50. So, and I'll explain, we'll keep a tally. We're going to run through this logically for probability and statistics and see what happens. So we'll have Susan be the one with the game show contestant choosing the door. So she's not here. We're going to use the dice to do the row and column. And so say row 2, column 4. So row 2, column 4. So we'll say this is her card. And so the riddle goes, if this is her card that she chooses, and if the game show host eliminates all but one, would you like to change your answer? So these cards can represent doors. Behind door number or whatever is the prize, could be the prize. So if this is her card, so this is what the game show does. Oops, I didn't mean to do that. Oops, stay there. Okay, the game show eliminates the field. This is the card that was originally picked. And then looking back to the contestant, would you like to change your choice? Would you like to go with door, whatever number that is? Yes or no? And common logic and wisdom, conventional wisdom and logic would now thus say this is a 50-50, equivalent of flipping a coin, heads, tails, 50-50, because it's either the prize, and oh, by the way, the prize in this, we're just going to pick ace of spades as the prize. Okay, that's the winning card or prize. It should be, conventional wisdom should be the same as flipping a coin because you got two doors, 50-50 odds. All right, so we're going to keep a tally of the probability and statistics as we go along. This is the door she picked. All right, for sake of this, Susan is going to stay with her original door just to keep a consistent to see what the odds are. If this is 50-50, it shouldn't really matter. She's going to stick to her guns with the original door, and then we're gonna have Dan play the antagonist and always be the other choice. What the game show would offer the other choice. We'll have him as that one. So this will be Dan's door. Okay. So round number 1. We might do this a dozen times. All right, 7 of whatever diamonds. Okay, the prize was behind the other door. Where's my marker? Dan gets 1. All right, I'm gonna have to do this a dozen times, so if you wanna fast forward to the end of the video, but now after the second round, I'll put a little more probability and statistics in the math. So bear with me. Oh wait, gotta get rid of that one too. Okay, let's set it up again. Get out of here, fly. Okay, we'll roll the dice. That way I have no control. Get out of here, fly. row 4, column 1. Row 4, column 1. So that'll be the contestants pick row 4, column 1, that card right there. So then the game show does this number here. Row 4, oh wait, row 4, column 1. Okay, that's, or row 4, yeah, column 1, that's right. It eliminates the rest of the field. Now, what are the probability and odds that your card makes it to the final round, or the finale here, the finalization, is, since there's 2 cards in the final finale out of, oh, by the way, that was a 36. 2 out of 36 is 1 in 18 chance of any 2 cards make it to the final round. But here's where the logic gets screwy. Your card is always in the final round. So therefore, it's not exactly 1 in 18. So that means more odds are in this one. So we're going to stick to our 50-50. Common logic wisdom says this is a 50-50 odds and probability chance. And for this contestant, we're going to stick with her guns. Okay, incorrect. And then we're going to have the antagonist play the one the game show. Would you like to switch your... Oh, the prize is behind door number whatever that was. 2 for Dan. Now, granted, if we were to flip a coin a dozen times, it might not exactly, and you're trying to call, you might not exactly get 50-50, like so 6 out of a dozen right. It might be 5, 6, 7, anywhere in there, or 4, 5, 6, 7, 8. It could vary. It might not be a perfect 50-50. So we'll continue the game. And if you want to fast forward to the end of the video, that's fine too. Get out here, fly. I'm gonna fly in here. So we're keeping track of the probability and odds of statistics. That it's going to defeat conventional wisdom and logic. That your odds and your original door is 1 in however many number of doors there are. In this case, there's 36 doors. So your probability, and I'll explain on this 3rd round here, and I might not even have to go to a dozen to get the point here. Get out of here, Penny. Okay, 36 doors. Contestant, row 1, column 3. So the contestant picks this card. All right. So now this is the card. We're going to eliminate. Now that means this card has 1 in 36 probability odds of winning, correct? Yep. That means the rest of the cards have 35 out of 36 odds of winning. It's somewhere in these 35 of 36. But if the game show narrows it down, instead of 35 others, down to 1 other, well, the logic is that 34 out of 35 odds is the other door. So this is your door, 1 in 36 odds of winning. So we're going to eliminate the field. So this is just all wrong doors, empty doors, no prizes behind those doors. So the field is empty, and for the sake of our keeping our tally here, she'll stick to her guns of that's the door she wanted for the prize. Okay, it's not ace of spades, and Dan's going to stick with the other door for consistency to track the odds. There's the prize, okay? 3 for Dan. 0 for Susan. Okay, I mean, you could flip 3 tails in a row. So it could still be 50-50. Still could be 50-50. So not too big of a deal yet, but again, if you want to fast forward to the end, that's fine. messy rows and columns here. Okay, contestant, since I can't, I'll have bias, so. Okay, row 3, column 3. So row 3, column, okay, contestant picks this card. So we're gonna empty the rest of the field. Okay. Okay. Emptied the rest of the field. Oops. So should be now. Is it a 50-50 odds that it's behind one of these two doors? Maybe. But with Marilyn Von Savant, her logic is no. This still, when you picked it, still had a 1 in 36 odds of winning, and the rest of the field had 35 out of 36 odds of winning, but the game show narrowed it down to this choice. So 35 out of 36 odds rests in this card, whereas your card had a 1 in 36. By the looks of it, it's down to 2. It's either in that one or that one. It's a 50-50. But that's, you know, conventional wisdom and logic would say. All right, you're gonna stick to your guns behind door number whatever that was. Nope, it's a 5 of hearts. Ace of spades. All right, now round 4. We'll do 2 more. I don't know if I'll do a dozen, but it's starting to get the picture. Starting to get the picture. Okay, 36 doors, contestant rolls. Oh, that's one of those hands. Okay. Row 2, column 4. Okay, this is the contestant's card. This is the contestant's card. Okay, 1 in 36 odds. So we're gonna, now 35 out of 36 odds is the rest of the field. We're gonna eliminate the rest of the field for you. Take these empty doors that had no prizes behind it. Okay, technically you have a 50-50 odds. Come on, cards, cooperate here. Should have a 50-50 odds. For the sake of tracking this, the original contestant's gonna stick to her guns with the original door, and the antagonist is gonna stick with the other option. Okay, what's behind the door of the contestant? Oh, 7 of clubs. And the prize is again in the other door. 5 for Dan, 0 for Susan. I still suppose, with a penny, I suppose you could flip 5 tails or 5 heads if you call it heads or tails, whatever. But it's starting to look not so good. We'll do one more just for demonstration. We'll do one more. Get out of here, fly. All right, I was going to do a dozen, but that's just going to take too long. But we'll get the picture with just 6 rounds. We'll go 6 rounds. Okay, 1, 2, 3. 1, 2, 3. Okay, the contestant is going to pick row 6, column 1, so that's this card here. Okay, we're going to eliminate the rest of the field. Okay, offer the contestant opportunity to change. Would you like to change your answer? yes, no, but for the purpose of tracking statistics, the original contestant's going to always stick with the original door just to see what the probability, odds, and statistics are with always sticking with the original door. If this is 50-50, it doesn't matter. Okay, they're going to stick to their guns. 7 of clubs. The prize is the other door. Whoop. So as you can see, it's not 50-50. I mean, I can keep going. Yeah. So it kind of illustrates it's when you have multiple doors and it narrows down. When they narrow down the field, go with the other door. But it doesn't work. It doesn't work when it's a 3-door idea. This is where I'll disagree with Marilyn Von Savant. So it doesn't work like this because, say, the contestant picks door number 1, and what they do is the game show will, of the other 2, they'll show you the one that does not have the prize, like that. Would you like to switch to the other one? In her logic, yes, because as we demonstrated 6 rounds of this, 2/3 of your probability rests in this here. I guess correct on face value. And 1/3 probability rests here, suppose. But the problem with the logic falls apart is, okay, so this card always has 2/3 more probability than my 1/3 probability. So are you saying as a contestant, I should pick this one, and then now this other card now has 2/3 probability statistics? Well then, wait a minute, then I'll stick to that, or what? Well then the other one has 2/3. So that's where the logic falls apart. No, in this case it is a 50-50 because there's always this other door always going to be eliminated anyway. So it's really a matter of 2. So that's where her logic falls apart. But it does work when you eliminate multiple doors, as we've seen, and we can go to a dozen, but that'll make a too long of a video. Hope that was fun. Did that too because when I was proven wrong, it was fun. It was fun for my brain to go, the aha, it clicked. I was like, wow, that was pretty neat.